So our final presenter of the day is Hadise Ibrahimi, who is a third-year PhD candidate in chemical engineering at the University of Alberta. The main goal of her studies is to analyze the risk of transporting hazardous materials by railway qualitatively and quantitatively for preventing or reducing railway accidents in the future, as well as enhancing the safety of railway transportation. She has published a paper entitled Analysis of Train Derailments and Collisions to Identify Leading Causes of Loss Incidents in Rail Transport of Dangerous Goods in Canada in the Journal of Loss Prevention in the Process Industries. Welcome, Hadise.
Good morning, everyone. Good afternoon, everyone. Can you hear me?
Yeah, looks good.
Thank you. Thank you very much for introducing me. My name is Hadise Ibrahimi. I'm a PhD candidate in chemical engineering at the University of Alberta, and the topic of my today's presentation is a risk analysis of hazardous materials release in railway transportation. After magnetic derailment, which is the fourth deadliest railway accident in Canada, 7 severe railway derailments transporting crude oil happened in Canada, which were listed in table below. As railway accidents are unpredictable, previous studies proposed different methods for performing risk assessment and risk management and calculating the potential consequences of hazmat release. However, the number of severe railway accidents, especially after the magnetic, and their destructive consequences of this accident reveal that there is still room for improvement in the area of risk assessment of hazmat transportation. So the objective of this study is to evaluate the potential consequences of hazmat release and to create a risk map for hazmat railway transportation in extremely populated areas. The features of the communities, such as population density and weather conditions, such as wind speed and wind direction, are changing over the time. So the risk is not constant, and changing factors should be considered to calculate and evaluate the risk. So a methodology is proposed in this study that can develop threats when created by hazmat dispersion and combine them with the population vulnerability in order to calculate the risk. The first step in our methodology is to model a hazard scenario. The potential scenarios of hazmat release are different based on the type of the release and the meteorological conditions of the location. So according to a purple book, loss of contaminant is classified for tankers into 2 groups, including instantaneous release, rupture of the tanker, and continuous release, or leakage from a 3 inches hole in the tanker. So in this study, we just consider these 2 types of release in order to model the hazard scenario. As predicting the time and atmospheric condition is almost impossible at the time of the accident. So in this study, we consider the most dangerous meteorological condition, which usually happen in stability class F, in order to model the hazard scenario. Air pollution is worse during the stable atmospheric condition, and it restricts the amount of vertical mixing. That's why we consider the stability class F in order to model the most dangerous meteorological condition. The next step in our methodology is to map human vulnerability. Social vulnerability indicators provide a means to estimate the population's ability to predict, resist, and recover from the hazard, and their inherent capacity of people to react to hazard. So population vulnerability is so important for developing emergency response plans in order to prevent the consequences of accident. In this study, the significant social vulnerability indicators, including population density, the population of female, the population of children, older and adults, and the population of people who don't have any certificate, diploma, or the population of people who can't speak official language, and etc. are considered in this study. And we acquire these social vulnerability indicators by a review of available literature and guidelines available by the government of Canada. Then we use a fuzzy analytical hierarchy process in order to find the importance and weight of each social vulnerability indicators and rank them based on their importance, because it's obvious that the importance of female population is not as important as population density. So we need to find the weight and importance of each criteria in order to be able to produce the accurate vulnerability map. The next step in our methodology is to map the risk. Risk is the function of hazard and vulnerability, and the social vulnerability indicators are combined with the hazard level of for each geospatial zone, and they are gonna be superimposed into the ArcGIS software in order to produce the risk map. In this study, we use these risk maps for risk assessment. This risk maps is a color-coded and is a central tool used for risk assessment, and level of hazard and vulnerability are categorized into verbal and numerical scale. Hazard categories are high, medium, and low, and these three levels correspond to the three output categories from the hazard analysis tool, ALOHA software, which is adopted in this study. And the vulnerability categories are very high, medium, low, and very low, and these five levels correspond to the output categories from human vulnerability analysis in the ArcGIS software. And in this work, the direct sum of the variables was selected because the risk matrix is rectangular, 5 levels of vulnerability and 3 levels of threat. An example application of this methodology is presented for a small city in Canada, and the scenario consider the potential train derailment of loaded crude oil tank cars, and 2 types of crude oil release, including instantaneous release and continuous release, are considered in this study. And the hazard maps are modeled into season, including winter and summer, and the variation is analyzed in the affected location. This table shows the results of threat zone acquired from the ALOHA software for each final scenario. We can acquire the final scenario using event tree analysis, and using event tree analysis, we realize that the final scenario of crude oil release that could have happened are toxic dispersion, flash fire, vapor cloud explosion, pool fire or jet fire, and BLV and fireball, and it depends on the type of release and other meteorological condition. As this table shows, the longest threat zone happens in stability class F in summer season, and when the final scenario of release is flash fire. And we are going to model this scenario, the scenario with the longest threat zone in the ArcGIS software. ALOHA shows a threat zone on a composite threat zone plot, and threat zones are differentiated with different colors. The red threat zone demonstrates the highest hazard, and the orange and yellow threat zone demonstrate the areas of decreasing hazard. Red, orange, and yellow correspond to hazard categories high, medium, and low, respectively, in the risk matrix used in this study. This figure shows the hazard map of the most dangerous meteorological condition, stability class F, in 8 wind direction, which was imported into the ArcGIS software. In this study, we try to consider all the wind direction in order to be able to produce an accurate risk map, because we know we can predict the wind direction at the time of the accident. So it's going to be a good idea to consider all the wind direction and produce an accurate risk map. Also, the wind rose is considered in this study, and we know in this case study, the wind rose is from the west to the east. So the people who are living in the east direction are considered to be as a high vulnerable people. The social vulnerability indicators were coded into the ArcGIS software to find the vulnerability map based on the census information for the area. As I've already mentioned, we consider different social vulnerability indicators, including population density, female population, and etc. And we developed this vulnerability map by combining all the vulnerability indicators into the ArcGIS software. And different vulnerability are considered for the people, including very high, moderate, low, and very low. And the last part of this work is to produce the risk map. Risk map is the function of hazard and vulnerability. And by combining the hazard map of the most dangerous meteorological condition and the vulnerability map in the ArcGIS, we could produce this risk map. The risk map can help risk managers to prioritize and optimize their actions to save people's lives in the hazmat release location. For instance, children and older adults are not quickly capable of escaping the hazmat release location. So they are vulnerable in case of evacuating the release location, and special help and assistance should be considered for them. The other example that I can mention is related to the people who are living in crowded houses. They might not be able to evacuate their places quickly, so overcrowding can cause a severe problem for them. So risk managers should consider special help and assistance for them as well. Incident involving rail transportation of hazmat can pose a threat to people living in extremely populated area. Risk analysis and risk assessment are necessary to inform decision making to reduce the consequences of hazmat release on people. In this study, the hazard map for the most dangerous meteorological condition is simulated using the ALOHA software, and the social vulnerability indicator, which have great importance in the risk analysis of hazmat release, are identified and simulated using ArcGIS software. By superimposing the hazard map and the vulnerability map, we could produce the risk map for the most dangerous meteorological condition. And this risk map shows the areas from higher risk to lower risk. This risk map can provide accurate information for risk manager to plan for land use planning in the future, and they can prioritize and optimize their action based on the characteristic of the people who are living in that location. Thank you for your attention. If you have any question, I will be happy to answer them.
Awesome. Thank you for that presentation, Hadise. It's very interesting risk analysis that you guys are doing. There could be a lot of work to get all the towns in the whole country done up, but it's going to be a really useful tool in the end. I can see that.